Now let's start from the beginning for this hands-on number 5. In any new project, we should create another folder for it. So I'm inside my working directory, working folder, downloads folder, and then I just create a new folder by right-clicking and then choosing folder and naming it as AERSCREEN 3. And then I need to refer to the PDF. Where's my PDF? And take note of the required executable files. I need 5 files. 3 of them have already been downloaded, while the other 2 I need to download from the e-learning portal. So I will just take it from the previous AERSCREEN folders. I'll just take it from the first AERSCREEN folder. Select AirMod, AERSCREEN, and also MakeMed. Right click and copy. Go backwards, go into AERSCREEN 3, and then I paste the 3 executables. Now I need to download 2 more. So this 2, I can get it from the eLearn portal. I go into the AERSCREEN.exe files page, scroll down and locate the executables, the BPI, PPRM.exe, and the make and the AirMap. I think it's just these 2, AirMap and BPPRM.exe. So click on that, wait for it to finish download, and the BPI, PPRM. Downloading both. I've already downloaded them, and it should go into my downloads folder. There it is, the 2 new executables. I just select both and I move it into the AERSCREEN 3 folder. So now in my AERSCREEN 3 folder, there are 5 files: the AirMap, AirMod, AERSCREEN, BPI, PPRM, and the MakeMed executables. Let's go back to the PDF. And then go to the next page. It says here the list of files needed for this hands-on. I need the DEM file. The DEM stands for the Digital Elevation Model, and it contains the elevation data, the terrain data for the site. The one that we are running right now is somewhere at the Seberang Perai area, in the Seberang Perai area, and that's why we call it Penang.dem with the extension DEM. If I'm not mistaken, this hands-on is designed around the Malakoff power plant station. I think you can see, can you see this screen on my right that shows the Malakoff power plant? So the DEM value is for this area here. So it is a bit flat because it's right beside the ocean. And there will be some areas that are less than the sea level, and that's why the terrain value for those areas are negative. But that is okay. It's just the nature of the land beside the sea. And the actual power plant is this. The power plant is actually a larger area. The entire power plant is somewhere in this region here, but then the source is this. You can see the stack, can't you? Can you see the stack? Okay, and I'm gonna zoom back out. So I need to download this first. This Penang.dem we have to create, but for this hands-on, I pre-created it so that it's faster for us to run this hands-on. But later on, I'll be teaching you on how to create this DEM file. This is the most challenging part, actually. But for this hands-on, I've already created it for you, so it should be no problem. And I need to download it from the eLearn portal. So it's not in this file here. It's not in this folder here. I go back one. And then I go into AERSCREEN input files page, into this page. And I see all the other files needed for the model. I'm going to follow the sequence given in the PDF. So I'm going to download the penang.dem file first. So it does take a bit of time to download, I think, but for me it should be okay because my internet connection is quite good. So it's finished downloading p9.dem, and then I think I'll finish downloading the rest first before I transfer it to the AERSCREEN3 folder. The next file is demlist.txt. This is actually related to this DEM file. It just lists all of the DEMs needed for the location. For this particular hands-on, we just need one DEM, but certain locations maybe require 2 or 3 DEMs, depending on how big is your modeling area. But for this situation, we just need one. So that's why in this dem list, there's only one dem p9.dem file. But for other situations, there might be more. That's why there's a dem list text file. Let me download that. And then after that, I'll download the conus.los, conus.las, and so on. So let me do that. I'll just download all of this. I think the rest you know all about this already. Except for this conus.los and conus.las. But this one, I don't have to go into detail. It's just that you always need to have these two files inside the folder, or else it won't run. So this is, and you can use this two files for any project, any air quality, air pollution modeling project. So you can think of it as just a file needed inside the folder only, without knowing much about it anyway. So going back, okay, let me download this conus.las and also conus.los, and I'll download the stem list, the land_cover.txt, and also the receptors.txt. Go back to the folder. We see all these files there. I'll just select all of them. Now I'll move it into the AERSCREEN3 folder. And inside the AERSCREEN3 folder, there are all these files. So let's take a look at one of the files. Let's take a look at the dem list file. I'll just double click it and show it to you. This is also something like the surface characteristic file. It has to be a specific format. So what I've given here is a template, and you just need to modify it based on your situation. In this case, we only need to use one dem file. So that's why there's only one DEM file here. But if you have like 2 or 3 DEM file, then the list should be below here. The exact name of the dem file should be written below. Dem list stands for the digital elevation model list, just a list of files. Okay, close that. The land cover, I think just like the one before, it's fine. We'll use this. And then the receptors. This is a new one. Now the receptors here, this first line is compulsory, but we can just ignore this, just leave it as it is. But like say if you want to determine a specific receptor, then you just need to specify the distance. In this case, it is at 1,610 meters, about 1.6 kilometers away from the source. It doesn't have to be, it's not an exact location, it's just the distance from the source. Well, this one is 1,700 meters, 1,750 meters. So if the source is, this is the source here, let me annotate. The source is here. So at 1,610 meters, it's something like a circle. So this is the sensitive, this is the receptor, the specific receptor that we like to study. And if it's like 1,700, then it should be a bit more and so on. But it's in the form of a circle, a radius from the source, and not an exact position. I think I covered most of the other newer files for this hands-on. The conus.las and conus.los, maybe later I will explain, but it's not important for you to know what they are. Just make sure that these two files are in the folder, that's all. And then cover, make math, yeah. So I covered all of it already. Now let's go back to this PDF. Oh yeah, some information about the discrete receptors file is the distance radius from the source. Might as well we just use meter, although we can use feet, kilometers, and miles, but we set it as meters. Maximum 10 receptors or 10 values, and we can edit the file in Notepad if you want to change. And then we come to the flagpole receptors. I did touch this a bit just now, so it's the same concept. Don't need to worry about that. And then this part we will revisit later because this is the challenging part. We need to create our own terrain data. Right now, we've already we already have the dem file, the Penang dem file, so that's why we don't have to go through this step. But I will still teach you this because for your own assignment, you need to create your own dem file for your location. Okay, I'll skip this for now. Oh yes, I did mention a bit about the conus.los and conus.las. This conus.los stands for contiguous US. It's just basically a file that contains information on how we project the coordinates. That's one of the reasons why I don't want to explain, because I would have to touch on what I mean by projection. In the area near the equator, like in Malaysia, we don't have to worry so much about projection because we are in a relatively flat part of the globe compared to the North Pole and the South Pole, where projections are more important. For example, this is the Earth, and this is the equator. We are somewhere here. Around this area here, the coordinates are pretty flat. So the projection is almost 1-to-1, right in the middle. But if you are somewhere here, you notice that these areas here at the top are closer to each other, while these areas here are further away because of the shape of the Earth. And how we map these values from this shape like that to become something like this. This mapping from here to here because of this area here is called projection. So difficult to type, to write, to draw. It's called projection, like oh, it's not written here. Projection. So the information to project from this coordinate to this coordinate here to become flat is inside this conus.los and conus.las. So that's why we need these two here. So like I mentioned, it is mandatory for the files to be inside the AERSCREEN folder. And we need to place the DEM file within the same working directory, like what we did just now. And we need to create the demlist.txt. So all these are there already. And these are the list, the example in the dem files list. For our current hands-on, is just for Penang, it's just one dem file. And we can proceed with this. So let me open up command prompt. And we'll follow along. So first of all, I need to navigate to the folder. Right now, I'm in the user folder. And I know it's inside my downloads folder, so I just type cd downloads, press enter. And then it's in the AERSCREEN folder, so I type cd AERSCREEN tree to go into the AERSCREEN tree folder. And I type AERSCREEN to run the application. Then I follow through. So let's type Malakoff stack title. This is the information here. I type it there. Metric unit, of course. Point source, P. Emission rate, I put here 100. Stack height. This is a very tall stack. You know, power plants, have very tall smokestacks, so it's about 150 meters, this Malakoff stack. By the way, this Malakoff power plant is running on coal. So the stack height is 150 meters. The stack diameter, we assume it to be 1 meter. It's actually quite large. The temperature of the stack is at 40 degrees Celsius or 313 Kelvin. And then we're going to use the exit velocity of with the unit ms, so 1. Exit velocity is at 10 meter per second, as written here. Rural or urban, if you look at this area here, we can clearly see that it's an urban area. So I type here U. Oops, what's going on? Okay, right. The population of the urban area, because it's in Penang, is somewhere around 500,000, 500,000 people staying around the area. The minimum distance. Now, the model, Gaussian plume model, breaks down if it's lower than 100 meters away from the stack. So that's why we don't go to the absolutely lowest value. We go to the generally accepted distance from the stack that the model can be applied, which is 100 meters. Anything closer would mean that it's going to be exponentially very large value of concentration. So that's why we put some distance between the stack and the minimum distance. So don't put it as 1 meter in general for other more realistic applications. And then since we are going to assume a conservative estimate of pollution, we don't put any chemistry. Anyway, we are not going to model NO2. We are going to model usually particulate matter or gases that do not degrade in the atmosphere. We assume it to be prevailing. It would persist in the atmosphere without changing to other things. So we just use 1, no chemistry or pollutant. No chemistry or pollutant is not NO2. Okay, in this case, we are using building downwash. So we'll just type yes. We don't have a pre-existing BPI PPRM input file, so we put no. Okay, what is the building height? The building beside the stack is about 20 meters. And the maximum horizontal building dimension from the stack is 100 meters. So the side that is facing the stack, the maximum distance. Okay, coming back to this one, the maximum horizontal building dimension is 100 and the minimum horizontal dimension is 50. Now maybe I can explain a bit about this. True north 100 direction. So something like this. So if it's a rectangle, then the maximum is this one, 100 meters. And the minimum is like that, 50 meters. If it's a square, just like that. And then maximum dimension to true north, 100. So in this case, it's actually 90 degrees because the north is here. So this this part here is relative to the true north, so that's 90 degrees. For this example, but for this example here is actually set as 100 degrees, so it's slightly slanted, something like that instead. This maximum distance, so it's slanted from the true north, that's why it's 100 degrees. And then direction of stack from the building center. So let's say the building center is this one. The direction from the stack is this angle here. It's getting a lot messy now. So let me try that again. I'll draw it more accurately now. The building looks something like this. This is the stack. This is 100 meters. Or this is 50 meters. The angle from true north is at 100 degrees, 100 degrees, and the center of the building is 26 degrees. Now, for this one, it's already stated here, but if you are going to do this for your site and there's a building and you want to apply building downwash, so you have to take note of that. Now, I know that sometimes stacks, there are a lot of buildings, other buildings around, like this building here, and so on. But you can only choose one. You choose the one that is the largest one that could affect. You don't have to take into account all the other smaller ones. So if there is if there are a number of buildings, just choose the biggest one, and the tallest and the biggest one as the um, as the representative, and use those dimensions for the building downwash. Okay, now I'm going to put in those values. So the explanation takes a longer time, but then to actually put the values are not that difficult. Maximum horizontal building dimension is 100, minimum horizontal is 50, and then maximum building dimension to true north is 100 degrees. Direction of stack from building center is 26.6. Distance between stack and building center is 67 meters. Okay, done with that one. Now, should we include terrain height? Yes. Maximum distance to probe, 10 kilometers. This is the maximum distance for the model to be valid, for the use of the model to be valid. So we shouldn't, even though we can actually model for a lot further, but the highest that we should is at only up to 10 kilometers. This is the absolute maximum distance that we can model, that we should model. Not we can model more, but we should only model up to 10 kilometers. Yeah, I think it's a typo. We can just ignore the terrain height here. We don't have, because we already skipped that. We go straight to the include up to 10 discrete receptors. Yes, because we do have a file for it. What is the name of that file? Okay, we refer to the folder. The folder, always make sure that you use the right name. So here in the folder, it's called receptors, and we know it's a text file. So we should name the file receptors.txt. Okay, sorry, wrong spelling. Receptors.txt. This name and this name should be the same, but you need to add an extension at the back. Don't forget the extension. Then press enter. Flagpole receptors, I don't remember. No. And then air map elevation. We're not going to use the source elevation. We're just going to use this air map derived elevation. So we press enter to use the air map derived elevation. And then we enter the coordinate. In this case, we are using the source UTM easting and source UTM northing, but we can also use lat-lon. But here we have that easting and northing UTM value, so we have to use this one. But I think it's a lot easier for your own case to use lat-lon, latitude and longitude, instead of UTM. But for this one, we just type UTM because we have the UTM value. Then enter the UTM easting value, which is this one. 65222.3.0, and then the northing value is 594.284.0, and then the UTM zone 47. And this is related to the projection. In this area we use this projection, the North American datum of 1983, so option number 4. By the way, in Malaysia, we would use this this option number 4. And this zone will be different for different areas. In Penang, it's 47. But this zone is only important if you use the UTM coordinates. If you use the lat-lon coordinates, this is not going to be a problem anymore. press enter, and then go to this one. The minimum temperature is 300, maximum temperature is 307, minimum wind speed is 0.5, and anemometer height is 10 meters. And then enter service characteristic option. So we are using the external file. Press 3. And what is the file name? Let's look at the folder. The file name is called lan, where is that? Lan underscore cover. So lan underscore cover.txt. Press enter. Oh, wait. Where is it? Just the external file here, and then you have to put the name of the file there. That's all. And then the name of the output. We just call it Malakoff. It could be any name you like. And then press enter. Then review all the information, whether it's correct. Check whether it's correct. And then you hit on enter to start run. So this will take a bit of time because it has to process through 10,837 values. And this is the rate that it's going. So it's still at 30 out of 10,000. So you can imagine it'll take about an hour or so. So that's why I say here, warning, this run might take a while, of about 1 hour, because we use terrain data now. That's the reason why it takes a long time. The previous time they don't use terrain, so you don't have to look at every particular location, but this one they do have to use it. So it's scrolling through all of the position of in the map and calculating the values. So it is calculating 10,837 times, more than that actually, for the values.